Okay, so we're going to be using multiplicative inverses, which are reciprocals, to solve equations. So like number 1 says 6/11 x equals 18. Now, don't write anything else down, but normally we would divide both sides by 6/11, right? But if I take 18 and I'm dividing by 6/11, can I do that? Yes. No, I can't. I have to multiply by the reciprocal, don't I? 18 over 1 times 11 over 6, right? Does that make sense? So rather than putting your wall up and dividing both sides by 6/11, we know it's the same as multiplying both sides by the reciprocal. Why is that? If I put 11 over 6 here, what happens to the 11s, Sam?
They cancel.
They cancel out. What happens to the 6s, Sam?
Also cancel.
And when we cancel, those are 1s. 1x is the same as x. So we do that to both sides. We have x is equal to, now I can put 18 over 1. Cancel the 6. 6 becomes a 1. 18 becomes a 3. And 3 times 11 is? Okay. We're going to check. Okay, we take 6 over 11 times 33. That 33 is rational, which means it can be written as a fraction, right? Right? 33 over. I want that to be equal to 18. Well, 11 will cancel. It goes into 33 3 times. 3 times 6 is, does it check? Yeah. There's nothing that you can simplify. All it is a fraction times the variable. Rather than dividing both sides by -7/13, let's just multiply both sides by the reciprocal. What is the reciprocal of -7/13? Hudson? -13 over 7. So we're going to multiply both sides by -13 over 7. Again, this negative times that negative is a positive. We don't want negative x. These are 1s, these are 1s. And we get x is equal to, that's 28 over 1 because it's rational. It can be written as a fraction. 7's going to cancel and become a 1. How many times does 7 go into 28? Positive times a negative is? 4 times 13. I always think of cards. And a lot of you don't even know anything about a playing deck of cards anymore. What do you get, Jared?
52.
Right? They're -52. There are 13 cards in each suit, and there's 4 suits, so there's 52 cards. Check it. -7 over 13 times -52 over 1. Negative times negative is a 13 goes into 52 4 times, right? And 7 times 4 is? I might be jumping ahead of the game here. Okay, is there anything you can simplify? No, there's nothing you can simplify. There's no like terms, there's no parentheses, nothing like that, right? What is the least common denominator between 12, 4, and 2? What is the least common denominator, Jack? 12. Watch this. I am going to use my distributive property and multiply by 12 on both sides. Okay? So when I take 12 times -7/12, what happens to my 12s? What happens, Sam?
12 to the second.
No, we're dividing them, right? That's 12 over 1, isn't it? This is really 12 over 1 times -7 over 12x plus 3/4 equals 1/2 times 12. Do unto one side as you do unto the other, correct? When I distribute, what happens to that 12 and that 12? They are going to cancel there. So this is going to cancel with that one, leaving me with -7x. Plus, then I got to take the 12 times the 3/4. Well, that's 12 times 3/4. You should be able to do this in your head. Doesn't this 4 cancel? What would it cancel out to be on the 12? 3. So that's a 3 times 3 is 9. That should be 9 equals, what's half of 12 on this side? 6. Doesn't that look a little easier to solve now? You don't have to do it this way. But here we're going to subtract 9 on both sides. We get negative 7x equals negative 3, right? Divide both sides by negative 7. And what's x going to equal? Well, negative divided by negative is a, and we get 3/7. That just makes it so that you don't have to deal with the denominators, but it's okay if you do. Okay, so if you were here, negative 7 over 12, x plus 3/4 equals 1/2. Okay, I'm going to show you the other way. Well, we subtract 3/4 on both sides. Right? These cancel. Keep change opposite. Common denominator is? So this is 2/4. So negative 7 over 12 x equals negative 1/4, right? Right? Multiply by the reciprocal on both sides. What's the reciprocal of negative 7/12? Negative 12/7. Okay, these cancel, leaving me with x is equal to negative times a negative is a 4 cancels, and that's a 3, and we get positive 3/7. Either way, you're going to get the same answer. Okay, so when you check it, you can put it right back up in there. Negative 7 over 12 times 3/7 plus 3/4. I want it to be 1/2. Okay? Well, 7s are going to cancel. That's a 1. That's a 1. 3 is going to cancel into 12. That's a 1, and that's a 4. Negative times a positive is a negative, and I get 1 times 1 is 1 over 4 plus 3/4. What do I get when I add those together? 2/4. Is that the same as 1/2? Yep. So it checks. Yep. We're going to add 5/6. 5/6, adding 5/6 to both sides is the same as subtracting a negative, isn't it? And check it. Do these two cancel? Yep. So this over here is 5/16 x equals, we have to have a common denominator. What's the common denominator between 48 and 6?
48.
So this is, Hudson, what do I take 6 times to get 48?
8.
So 5 times 8 is?
40.
So now we can combine them, right? We get negative, no, positive 35 over 48. Correct? Okay, now let's multiply both sides by the reciprocal of 5/16. What's the reciprocal of that, Tessa Ortman?
16/5.
16/5. And ask yourself, do these cancel? Hello? Okay. And we're left with x over here equals, well, 5 is going to go into 35 how many times? 7, not 6. Does 16 go into 48?
Yeah.
How many times? So here I get on top, I get 7. In the denominator, I get 3. I am not making that a mixed number because I have to change it back to improper when I check. Okay? So let's check it right back up in there. We're going to take negative 5/6 plus 5 over 16 times 7/3. I want it to equal 5 over 48, negative 5 over 48, okay? Does anything cancel here? No, so go straight across the numerators. I get 35 over 48, right? Right? I gotta make the negative 5, 6 out of 48, right? So multiply that by 8, that's negative 40, isn't it? Oops, 2 negatives. That's negative 40. So I get negative 5 over 48. We're going to let x equal the number of years to reach 25 feet, right? It's already 10 feet. It's growing 2.5 feet per year. So it's 2.5 times x equals 25. Do you notice that this is a mixed number? Can we have a mixed number multiplied by a variable? No. So instead of putting 2.5 there, we're going to put 5 over 2x. Okay, Christian, what do we do now?
We would, subtract 10 on both sides.
Yep. And we get 5 over 2x equals, what, 15? Then what do we do, Jacob?
We multiply 2/5 on each side.
Yep, multiply both sides by 2/5. These cancel, leaving me with x is equal to, that's rational, right? 5 is going to cancel. This is going to become a 3. And what do we get for answer, Jackson?
6 years.
6 years. Do you think tree companies need to know this? Yep, they sure do. Okay?